You know,
especially the multi-tenancy part of it on Azure Stack
oh
HCI.
yes, indeed, yes,
Yeah.
indeed, yes. Well, it's quite nice. I'm looking out of my hotel room going, oh, yeah, Singapore is exactly the same temperature as it always is all year. 30 degrees and humid.
But I'm sure in the hotel it's okay, right, Phil?
Sorry, no, there was a lot I just got some background interference then. Sorry, Noel, say that again?
I'm sure in the hotel it's okay.
Yes, the hotel's fine. Yes, indeed. I made the mistake of going outside yesterday. I won't be doing that again. You know, how you live in Malaysia, I do not know, you know.
We are used to it, Phil. We were born
True.
lived here almost all our lives, so it's one of those things. You
Yeah,
just get used to it. You accept it as it is.
true. Well, what I always like though when I'm around KL is just how green it is. Though, you know, I love how green and lush the whole of Malaysia is. You know,
Understand?
yeah,
Yeah.
yes,
Thank you. Thank you. It is very green. Cool. I
yeah.
think we should get started so that we don't keep those who are punctual waiting. Okay. Welcome everyone. Thank you so much for making time for this session. All right. It's been a while since we have had Phil back. I think the last session that we did, Phil, was it like 2017 or something?
I think it was a long time ago. Yes, and then a global pandemic got in the way. But yes, it's been a while. It has been a long
Yes,
time.
indeed. Yep. So Phil and I've been catching up on some emails and so forth, and also some meetings in India, and so we decided that we felt that it was important to do something for the community in this region. So I reached out to him and I asked him for this big favor to do a session on designing a highly performant and reliable Azure Stack HCI. So covering around the best practices of it. Okay, so we're not going to go to a specific feature and deep diving on that, but we're going to look at the overall and see how we can pull together the best practices for a highly performing and reliable system. Okay, so I'm just wondering, Phil, before we jump into it further, maybe you can give us a bit of introduction of yourself and some of your recent work in the past 12, 18 months.
Of course, yes, indeed. So
Yeah.
for those of you who don't know me, my name is Philip Moss. I'm Chief Product Officer of an organisation called Accutech, and Accutech is a global services organisation who specialise in building solutions on advanced Microsoft technologies. And I, for many years, and some of my colleagues have worked very closely with Microsoft Engineering, really focusing on pushing the limits of what is possible with some of the core Windows technologies and some of the Azure technologies. And over the last 18 months or so, I've spent a lot of my time working with opportunities and working with partners, designing a number of very large, at scale Azure Stack HCI deployments, and also working with other organizations who are deploying at scale. So deploying, many thousands in some cases, either single node or two node solutions, where the raw performance of Azure Stack HCI is delivering on their core storage, network, and compute requirements, in these remote locations, but then leveraging Azure and the benefits of Azure as a control plane to give them that scale and that manageability. So yes, that's what I've been doing. And also for the wider audience, yes, for my sins, I was involved in validating many of the technologies we're going to talk about today. So when they don't work, you can blame me, basically, or just blame Noel. It's up to you, indeed. So hopefully that gives you all a nice introduction.
Thank you, Phil. Thank you. I don't know if we can call it sins, right? If you do, then I feel very deeply sinful, all right? Because it's something that we talk about all the time, every day, right? So
Indeed.
thank you so
No, I
much for
agree.
that wonderful introduction. If any of you have questions, please feel free to drop them into the chat window, yeah? All right, so I tried to do a little bit of, if you want, PowerPoint slides, even though we're not going to do a lot of that, but we want to jump straight into covering as much as possible around understanding key aspects, if you want, that can help us draw on to provide a highly performing design, right, with Azure Stack HCI. Phil, in the last 18 months, I'm sure many people, like you mentioned, has come to you for help. right? With all kinds of different requirements and so forth, right? What can you share around design aspects of Azure Stack HCI that can give us that amazing performance?
Sure. I really like this question because people, when they think about infrastructure solutions, which is what Azure Stack HCI is, tend to get very obsessed about, the amount of RAM or the number of cores or the CPU being in use, right? Or they get very fixated about the type of storage subsystem, the physical disks they're using. But the point is, all of that is actually irrelevant. So the most important thing when designing a high-performance system for Azure Stack HCI is component balance. Let me explain what I mean by that. A high-performance Stack HCI system doesn't necessarily mean a system that is running the absolute highest IOP numbers. A high-performance system is one that is running at the best possible performance based on the components that are in the system to do the job it's designed to do. Let me explain what I mean by that. So let's deal with some simple concepts. If you've got your storage, you want to make sure that your networking can drive the storage I/O, right? You want to make sure that the amount of storage across the cluster is balanced against the type of virtual machines you're running, and again that your CPUs are aligned against the amount of RAM you've got. So actually balance and building your systems to the workload is my first, kind of high performance thing. So I'm going to pause there and let you all digest that, because I'm sure that's going to fire off some questions.
So Phil, you're saying that the balance between the different core components is possibly the most important part for performance?
Absolutely. Let me give you a great example. And I was actually chatting with a large OEM who will remain nameless, in fact, yesterday on this very subject. So they were designing systems that were pure NVMe plus SSD, right? So these are NVMEs that can write, 600,000 or 700,000 IOPS a second, but they were planning on putting in 25 gig networking, right? In other words, they were going to be limited on the performance of the networking. So they might as well have put in spinning hard disks because they were completely choking the performance of the NVMe.
Yeah.
Yes. And this is a key thing, right? So first things first, it's about designing systems that are based around, one, your requirements, and two, making sure that you're actually driving all of your hardware components at their maximum. Because there's absolutely no point buying some hardware. So go ahead, Noel, all yours.
Oops. You still there, Phil?
I am indeed. Yes, can you hear me now?
Yeah,
Yes.
you kind of disappeared for a couple of seconds.
Oh dear, the dreaded internet connection. But anyway, we'll keep going. Did I make sense, or did you lose me?
Maybe you can just repeat the sentence.
Of course. So the last point I was making here is that at the end of the day, the hardware components in your system cost money. So you never ever want to not get 100% out of every single component. So if you're going to put expensive storage in, put the correct networking to drive them in, etc., etc.
So based on the example that you just mentioned, say if you're using NVMe as cache and SSD as capacity, and you're saying that 25 gig RDMA is potentially not enough, right?
Guaranteed, in fact. It will never be enough, because if you look at the basic performance of even a slow NVMe, it's going to saturate a 25 gig network adapter. Remember, it's a network adapter is only going to drive, 2 gigabytes a second, and a 700,000 or 800,000 IOPS a second NVMe can drive in excess of 4 gigabytes a second.
Okay, so I guess the next what will be the next RDMA performance that we can look at beyond 25 gig?
Sure. So what's also interesting is that 100 gig right now is tremendously cost effective, right? And in fact, when I'm talking to people nowadays, I just say put 100 gig in anyway, especially if you're doing RDMA direct, because you're not paying for the switch port costs, right? Okay. But yeah, that's an absolute baseline. And obviously the 800 gig is now available, but very, very, very expensive. But the the 400 gig when I'm running pure NVMe systems is my recommendation these days.
Okay. Okay, cool.
But remember that you need you've got to have Gen 4 for 400 gig network adapters, otherwise you're just not going to drive the I/O through the PCI port.
Yeah, I thought so. So when you say 400 gig, I'm just curious to know what adapters that are out there. I know ConnectX 6 has 100 gigs, but I haven't heard beyond that. I think that's Gen 3. Have we lost Philip?
Jane?
Yep, can you hear me?
Yeah, I heard you, but just can you just repeat the sentence for Phil? I think his connection on his side may be a bit choppy.
Yeah, so yeah, I think my question is, I was just curious to know who are these network CNA manufacturers who actually do 400 gig, and I think Philip also mentioned 800 gig. Because as far as I know, right now, I think you have ConnectX 6, which is the Mellanox, can do 100 gig.
Okay.
So I was just curious to know. I think we dropped off, I guess.
Phil, you still there?
I think he dropped off.
Okay. Then we'll give him a minute or two to come back in. I'm just trying to capture. Hey, and Jane, for the benefit of the rest, maybe you want to drop your question into the chat window, right?
Yeah, sure.
We'll get Phil to circle back on. Oh, here he is. Hi, Phil.
Hi, apologies everyone. Again, I'm so sorry. Someone was asking me a question. I'm so sorry. There was a question about the network speed. Please repeat that question. I'm so sorry.
Yeah. So yeah, that's just me, Jayant. The question that I had basically is, as far as I know, there is a ConnectX 6 from NVIDIA which can do 100 gig today. So I haven't heard of adapters that can do 400 and 800. So just trying to understand, who are these, what are these network cards?
Right, a good question. So the ConnectX 6, there's a 400 gig version of the ConnectX 6 publicly available. I don't believe, so the ConnectX 7 is an 800 gig card. I don't believe the ConnectX 7 has shipped yet, but you can get the ConnectX 6 in 400 gig today, quite happily.
Oh, okay. I didn't know that.
Yes.
Okay, cool. Yeah. That's awesome.
Yeah. Yes. But pause for a second, because remember, that doesn't mean that validated hardware from the vendors have components. Yes.
Great.
So yes, that's just because the ConnectX 6 is available with it doesn't mean that Dell, HPE, Lenovo, etc. are supporting that version of the card.
Not yet. Yeah. So I think to your point, right? So I think they are well ahead in the game. I am not too sure if there are any CPU architectures that still support PCI Gen 4 yet, at least have been validated and certified.
There are many PCI Gen 4 systems out there.
Okay.
All of the systems that shipped last summer, which again, I never keep up with Intel naming conventions. It wasn't Ice Lake last summer, was it? What was last summer's? It was Ice Lake, wasn't it?
Yeah.
Ice Lake, yep.
Yes.
Yeah, Ice Lake is PCI. Ice Lake is Gen 4.
So what is the requirement of the 700 gig ones? Is that Gen 4 or Gen 5?
Right. Okay. So the 800 gig adapters are being aimed at Gen 5 PCI, correct? Not the 800 gigs are not commercially available as far as I know at the moment.
Okay. Got it.
Yes.
Cool.
Yeah.
Thanks.
But these are really important questions, because as you guys on the call know, because we all know Storage Spaces Direct well, Storage Spaces Direct isn't really a storage solution. It's actually a networking solution, because if you don't get your networking right, you forget the storage. Yes, exactly.
Phil, when you say it that way, right, you're probably going to lose all the folks in here except for yourself and Hitan, I think. If you say PCI is not Azure Stack HCI is not a storage solution, it's a networking solution, then we are in trouble because our networking skills are very poor.
Well, I was never into networking until I had to get good at Azure Stack HCI, so it's not that difficult.
And especially to those sales and pre-sales specialists out there who are trying to retire their quota on storage, it's a bad news for them. No, I'm just kidding.
I couldn't possibly comment. Although I was sitting in a meeting in Sydney the other week with a young chap who was trying to tell me that fiber channel storage was far quicker than Ethernet-based systems could ever be. It got slightly embarrassing when I pointed out the fiber channel's maximum speed is something like 120 gigabits a second at the moment. So it did get slightly embarrassing, but he was desperate to tell me that his SAN was much faster than storage space as direct could ever be.
So, Phil, apart from the core components that you talked about, right? So you have the cache, all right, that gives us that really high performance, and then we have the east-west, the connectivity that we talked about, that 100 gig, that 400 gig per second. All right. Any other important aspects?
So my other big one is up the node count. So again, because the performance of the subsystem increases in a linear factor, the more nodes added to the system, the more nodes you can add will dramatically increase performance. So if you want to use very high performance systems, you want to increase node count, so you end up with more nodes, even potentially with less RAM and less CPU cores per node.
Okay.
Yes. And remember, because we pay for Azure Stack HCI per core, there is no disadvantage in having more nodes with less cores than fewer nodes with more cores.
Can you repeat that?
Okay, so let me go back in time. Remember when we licensed Windows Server, you had to license Windows Server Data Center Edition with a minimum of 16 cores.
Correct.
Okay, so there was a point where if you had less than 16 cores per node, it wasn't cost effective to increase the number of nodes because you were paying for Windows core licenses you weren't needing, basically. Yep. Okay.
Right.
Yep. With Azure Stack HCI, because you literally pay for the cores, it's actually sometimes worth increasing node count because that will drive performance, because you're not wasting Azure Stack HCI licensing on nodes that you haven't got or aren't using. Does that make sense?
Yes.
Yes. And for the wider audience, the reason this is important is because the way storage spaces writes data, it will actually parallelize the writes across, in fact, all nodes in the system as it does a write, using the way it chunks the data. Therefore, the more physical disks you've got involved, you will get fantastic performance increases.
Okay. Okay. Good point.
Yes, absolutely. And the last one I'm going to talk about, which is what everyone always forgets about, is, for goodness sake, use the CSV RAM cache, because no one ever uses it. And it's a free way. You can turn it up to 64 gig, and it's a free way to have read acceleration on all of your CSV volumes.
But isn't that turned on by default, Phil?
It is, but it's not set to the maximum size.
Okay.
Yeah.
Got it.
Yeah, by default, it's not set as large as it can be.
Sorry, I think I missed that part. I didn't understand. Can you repeat that, Phil? What is that you need to turn on? Okay,
the CSV is what's known as CSV RAM cache, or the CSV read cache. It's a piece of functionality that actually has been in Windows Server since Server 2008, but effectively each node will cache CSV volume reads. So if there is a read that's already been pulled from disk, it's in RAM cache, your read performance is incredibly fast.
And what was the size that you mentioned? 64 gig?
64 gig is the maximum size it can be.
Wow.
Yeah.
Okay, because I know the Sizer tool on the Azure Stack HCI catalog actually does have an option for that. But I don't.
Oh, good for them. Well done, Cosmos. You've actually included it. Well done. Good for him.
I remember seeing it. It's just that I don't ever remember it going beyond 1 gig for that size. by
That's
default.
because that's the default. That's the default size.
Yeah. Okay.
Yeah.
Got it. So we can just turn that option on and just up it by
Yep.
maybe,
Yep.
I don't know, maybe 64 gigs, a little bit high, but maybe
That's the point. It's a trade-off. You get it as it is a trade-off because obviously you're confusing you're eating up RAM that
Yep.
could be used for other things like running virtual machines. So yes, it's always a trade-off and a choice, which is why they set it quite small by default.
Got it. Got it. Okay.
Just share the link on the chat. I'm not sure that's how you enable it.
I did briefly see the commands. They looked about right. Oh, good, perfect. You got the link. Perfect, good. Yes, indeed.
Yeah, if I would just bring up the size, if I'm not wrong, it's somewhere in here. There you go. You're talking about this one, right?
Forgive me. I'm just.
Is the shared screen coming across to your side, Phil?
It is. Yes, it is. I'm just peering. Yes, that looks like it. Yes, indeed.
Yeah.
Yep.
Because I notice it's always on by default, at least in the size, and it's set to.
Oh no, well, it is because since Server 2019, it is on by default.
Yeah.
Basically. Yeah, indeed.
So what you think is we can push it as high as 64 gig per node.
Yep. Yep.
Okay.
I'm really glad that they are including that as a setting because it's an important thing to be enabled, and I'm glad they finally care about it.
Okay. Very good point. I've not seen this being added or being included as a best practice from a performance perspective, but I think this is a very good point. Yeah.
It's incredibly important because it's basically free I/O if you think about it, because it's avoiding calling to the. Yeah, exactly. Now, while we're here, by the way, shall we talk about storage class memory or NVDIMM and the performance benefits of using that?
Yes, please.
Okay, so let's just first of all deal with the headline thing. Storage class memory, almost no one needs, because the only people who need that sort of storage latency are trading banks, basically.
Okay.
Right? Because you're in a nanosecond in terms of latency. For those of you who haven't worked with NVDIMM before, there are 3 ways you can make or use NVDIMMs. One is basically a slow RAM, which I've never understood why people would use them as slow RAM because it just seems pointless. One is in application mode, which applications like SQL or databases can use basically as dynamic cache, which also to me seems stupid because just buy more RAM. But the most interesting use is you can use it as block storage. And because you can use it as block storage, you can use it as the storage bus cache in Storage Spaces Direct. So if any of you really want to build the world's fastest systems, go and use storage class memory and use that for storage bus cache, and then back it off with some NVMe and do a 3-tier storage system. So you go storage bus cache, so you go NVDIMM storage bus cache, then you go NVMe for your first tier, and you go SSD for your second tier. And if you do that, you can actually build systems that run 25, 27 million IOPS. So yes, if we all want to do benchmarking, it's fantastic fun, but not a lot of use in the real world, actually.
Amazing. How many?
It is.
How many?
Go ahead, sorry.
How many nodes
60.
would you need to get 25 million IOPS?
If I'm not wrong, Microsoft and Intel did a joint, what do you say, white paper or something that stood at around 13 million IOPS for 12 nodes. I think that's what I read, right?
That's the famous SQL. That's the famous SQL benchmark. The so many IOPS off 12 nodes, but 16 nodes. But at the end of the day, it comes back to the node count thing. Your performance increases in a linear manner the more nodes you get. So that's why you drive those incredibly high I/O performance figures using storage class memory.
So Phil, what's your opinion on Intel Optane persistent memory instead of NVMe?
So NVDIMM, in other words, right?
Yeah. Okay.
Yeah, that's NVDIMM or persistent memory, PMEM. So I think I've covered that fairly well already, already basically. So,
Okay.
PMEM is basically RAM modules with SSDs on the back to allow them to be persistent, basically. Yeah. And NVDIMM is the generic industry standard for, what is known as PMEM or, what was it called? Optium. No.
Optane, Intel Optane, yeah.
Yeah, no, Optium. What does Intel call its shipping version?
They call it as Intel Optane persistent memory or something. IOPM.
Low pass.
Yeah.
No, Apache Path. Yes, that was Apache Path was the development label. I forget what they call the shipping thing. Optium. What do they call it? The shipping. Their commercial name is called Optium. No, not Optium.
Optane.
Optane. Optane. Thank you, Noel. Optane. Yes.
Optane,
So
yeah.
Intel Optane. Thank you. And the problem with Optane is that they have two products under that same name. So they have very high performance NVMe and they have persistent RAM, both that they call Optane. Because you've got to love Intel's odd naming conventions for their hardware. Coming back to my earlier point, though. No, so go ahead.
Yeah, what is surprising is, I'm not seeing NVDIMMs being extensively used on Azure Stack HCI, but I've seen that being used on Windows Server. That's an interesting one. I'm not sure if Phil, if you have seen, vendors using.
Do you want the official answer or the honest answer?
I want the honest answer.
So, Azure Stack HCI has a validation program. The vendors have to put their servers through the validation program, which means they have to provide hardware to Microsoft, and the hardware costs money. So they're only going to validate systems that they are likely to see a certain amount of mass market appeal. It's that simple.
Got it.
It's also why there is no integrated or certified node that is 3 media type.
The 3 media type, as in the NVMe, SSD, and spindle?
Correct. Yes, indeed. There are none of the tier 1 vendors have a certified configuration using 3 media type.
Why? That's not going to make it too expensive, would it?
I know it's not about cost, it's about complexity. As we all know on this call, 3 media type requires the user and the customer to have an understanding of what they're doing. And of course, most of the customers don't, and the OEM staff themselves don't know what they're doing. So they stay away from 3 media type because it's too complicated. That's the problem. It's the same reason that a lot of them, especially Dell, just do single media type, because it just removes the ability for the customer to get it wrong.
What is the complexity, if you can share more on the 3 media type?
So if we think about 3 media type, the place 3 media type is very beneficial as if we're doing mirror accelerated parity, because cache is there and it's actually running in front of both the front of the SSD and the spindles.
Yes.
But of course, what you're doing with a mirror accelerated parity volume is you're having some 3-way mirrored stuff and then being rotated into parity. What you do is that you have the 3-way part of the volume run on the SSD, accelerated by the NVMe, and then you rotate later down to the spindles. Well, from a planning point of view, that means that you need to make sure that your SSD tier is the correct size for your 3-way part of your map volumes, and the 3-way part of your map volumes really needs to be the size of your daily working set. In fact, your daily working set needs to be 60% of the size because it rotates at 60% full. Sorry, 70% full. So there's a whole bunch of complexity and understanding there that, frankly, most customers and most salespeople inside of a tier 1 OEM just do not understand. I've actually had this conversation. I've actually had this row with Cosmos because I'm like, will we please do some endorsement of 3 media type? And he's just like, nope, don't want to do it because it makes it too difficult for us to simplify things. So yeah, that's why you will never see a tier 1 OEM ever do it as an Azure Stack HCI system.
Okay.
Yeah. Agreed. So
there was a question there. What's daily working set? What about say? Forgive me. What was I about to say? Doesn't our tool take care of that? Oh, sorry, Hitan. Yes, correct, Hitan. Yes, that's absolutely the point. Yes, our tool absolutely, Hitan, takes care of the daily working set, because I'm glad you brought this up, because it takes the complicated calculation out of the way. Yes, indeed. Sorry, Hitan, I didn't. I read the question, not the person writing it. Sorry, guys. Go ahead.
It has to be 1 minute and 10 seconds.
Yeah, I think you're right. So, Phil, so I think from Dell perspective, validated on Windows Server, which is the Optane memory, is something that that's validated on Windows Server only, not on Azure Stack HCI. Okay,
Exactly.
now I know. Yeah. Now I know. Okay, cool.
And also, here's the other key thing. Windows Server, hyperconverged solutions built on Windows Server, in other words, storage spaces, direct SDN, and Hyper-V, also have a very strong future. So here's where it gets very interesting. I look at the telemetry regularly. It's still the majority of deployments are Windows Server, not Azure Stack HCI.
Mm-hmm.
And the other thing to bear in mind is that today, your infrastructure solutions real job is just to run Kubernetes, right? So we're slightly going beyond the scope of today's conversation, but the days of virtualization with VMs are dying, okay? The future of virtualization is containerization, because containerization is more efficient. If you're going to containerize things, Kubernetes has become the dominant clustering platform for containerization on Kubernetes, and therefore really want a platform to run Kubernetes easily, and really that's Tanzu, OpenShift, or AKS. Well, OpenShift and AKS run on top of VMware, Windows Server, and Azure Stack HCI. So in fact, Windows, from the Microsoft perspective, Azure Stack and HCI and Windows Server base both have a very strong future, because all of Microsoft's managed hybrid services going forwards are built in containers, all of them.
Wow.
Yeah. Well, think about it. SQL managed instance is a containerized workload. Yep. Percept is a containerized workload. You know, the application run, the web application services runtime is a containerized workload. That is the future.
Awesome. Well, I guess that gives us a very good closure to this part about being highly performing, right? Customers want highly performing apps, right? And that means that even from Azure HCI perspective, what you probably end up having is customers using containers and AKS on top of it, right? To get the highest performance.
Spot on. And this is a nice way to finish it off. That's why having high-performance storage delivered through great networking to make the hypervisor work efficiently is absolutely key, because then your virtual machines and your containerized workloads run well.
Cool. Awesome. Thank you. If any of you have questions around this area, do drop it into the chat window. We'll try and take it towards the end. I'll try and leave some time for Q&A as well. But the next bit is equally important. I'm sure many customers don't buy something that's just super duper fast that breaks down every other day. So obviously reliability is very important for many customers, right? So the next bit that I wanted Phil's help to, if you want, expound on is actually what are the important aspects that affect reliability, all right, in Azure HCI. Phil?
Good. I'm going to say some controversial things now. So
sure, go ahead.
let's get into the absolute basics. Azure Stack HCI, and let's ignore the single node disaster at the moment. I'll come back to the single node later. Azure Stack HCI is a highly available clustered platform. The reason I start with that is that means that the fault domain, your point of failure you care about, is the node. Okay? So the reason that's important is that I get really irritated when people run around and say things like, oh, I'm going to put in 2 power supplies and a redundant RAID control to drive my operating system, and backup networking this and backup the other, right? When actually it doesn't really matter, because when the node fails, that is your fault domain, right? So actually making the node more resilient doesn't actually improve your overall system availability. Now, I know that most of the tier ones will always supply redundant power supplies and all these other bits and pieces, and that's absolutely fine. But if I'm actually designing Azure Stack HCI hardware from the ground up, I make all the components inside my node not highly available, because my node is my reliability point, my fault domain. Now I've moved beyond that point. Therefore, how do I design reliable systems? First things first, right? Obviously, we take advantage of node scale out because that drives availability. You know, if I'm working with 2 node systems, I will always use nested resilience. In fact, I like using nested parity because that obviously gives us fault protection. And also, and I will take some questions in a minute, the other key thing I do, which is absolutely key, is I make sure that my networking is truly redundant, both in terms of all nodes having multiple paths up to the core switching, but also the core switches having the correct cross connects so there isn't any contention. Let me explain why that's important. One of the things I see happen all the time is people say, oh, yeah, I've got an 8 node system, hypothetically, and I've got my 2 switches, my 2 top of rack switches, and all of my servers, all of my nodes are connecting to both switches. Wonderful, great. And so they say I can tolerate a switch failure. Well, great, except they've only now got, say, 2 or 3 cables between the 2 switches. So actually what happens is that if they have a catastrophic network failure, they might have redundancy, but actually they haven't got the capacity east-west on the switching. So actually they just hit a great big lump of contention on the top of rack switches, right? So, you know, and we'll open this up for conversation. So my initial takeaways are, don't build redundancy in per node, use multiple nodes to drive your redundancy, and make sure that your network switching has suitable connectivity so that when you have component failures, you aren't automatically hitting contention on networking, because otherwise you're going to have unstable systems. So let's start that up as an opening point. And by the way, we can get into other conversations about write intensive and read intensive SSDs and some other bits and pieces, but I'm sure my comments are going to fire debate. Everyone's very quiet.
Sorry, Phil, were you waiting for us to ask?
I was going to see if anyone had any comments on what I just said.
It's true. I agree. Totally agree on that.
Good, even better. Right, okay, that's a nice thing. Now let's talk about other things that are important to actually drive reliability. Right, we've spoken about the obvious things like the correct networking, right, and making sure that, you know, when we're using our storage bus cache drives, we are making sure that we are using write intensive drives. Now I appreciate this is a problem these days because a lot of the manufacturers don't like providing 10 drive write per day drives, but you know, you've got to have those drives that are supporting at least 3 drive writes per day. But of course, then in our capacity tier, it doesn't matter so much, and we can use some of those cheaper, lower grade SSDs because it doesn't matter. Other things in terms of reliability, and this again is where solid state benefits over spinning Rust, because of course spinning Rust disks fail all the time, but solid state doesn't, so you're just maintaining things less option. Now, let's go and talk about the single node scenario, shall we? So I'm assuming everybody on this call is aware of the single node. The single node, again, as I'm sure you're all aware, is technically a single node cluster, which is fine because you've always been able to create single node Windows clusters, and it works exactly the same way as any other system does, except that the storage spaces direct pool uses per disk fault domains rather than per node fault domains, so that 2 or 3 copies of the data are maintained on a single node. So you can lose 1 or 2 disks. Obviously, if you lose the node, the entire thing goes offline. Now, the single node solution, I hate that Microsoft positions this as an HCI solution because, as we all know on this call, it's not. What I wish they had done is positioned it as this is an Azure consistent endpoint for people who want to treat Azure Stack HCI as a device that is controlled from Azure to execute Azure services. And in that scenario, Azure Stack HCI single node is an absolutely fantastic solution. Right? For users who want to replace their dusty server sitting in the corner and don't want high availability, frankly, I would go and take a Windows Server 2022 box, either run Storage Spaces Lite, which, by the way, did ship in Server 2022, or frankly use a rate controller, right? Because it's a better platform for that sort of customer. No, I think you're about to make some comments.
No, I was just thinking aloud. Yeah, sorry.
No, it's absolutely fine. I suspect the people on this call have a similar viewpoint from this point of view. Something else while we're here and we get into reliability, which a lot of people don't think about, is the whole driver firmware cables point of view. So one of the challenges, as we all know, with any clustered solution is trying to keep stability across the platform. And again, one of the problems I see often when I'm looking at broken Azure Stack HCI deployments is simple things like they're using the incorrect drivers or the wrong firmware, or they're not consistent across the nodes. The number of times I've seen people go, "Oh, this is a Dell R740," and they just randomly install whatever the latest drivers for the R740 are onto it, and then wonder why the system isn't particularly stable because it's incorrect drivers to actually allow the, SCSI enclosure services or the networking to work correctly, right? So again, the other thing in terms of reliability is make sure you are using the correct drivers and firmware across the board to actually, make sure the system is stable, and the last thing, and then we'll get into other conversations here, is for God's sake, look at the event viewer. And I know it sounds like an odd thing to say. The number of organizations who sit there and say, "Oh, yes, our Azure Stack HCI system doesn't work properly," or, we reboot a node and the volumes go offline, or randomly the system stops working when we run cluster-aware updating. And I say, okay, have you looked at the event log? No. Oh. Well, how have you been triaging it? Well, we just hoped. If you're trying to get reliability, or more importantly, triage reliability, use the event log. Triage the problems. If you're seeing I/O errors, solve them. If you've got RDMA collisions, solve them. And this now brings me to my last bit about reliability. The most common bit for an Azure Stack HCI system fault is incorrectly configured RDMA. Either because the following: incorrect drivers have been set up, packet size in MTU or jumbo frames isn't set up properly, either on the switches or on the network adapters itself. Now, again, as the people on this call will know, ATC arrived in Azure Stack 21H2. Yep. ATC does take care of a lot of this for you, but it doesn't really sort out the switching. So sorting out these basic network problems really does lead to a more stable system. And I'm going to pause there.
Okay. Phil, question on the volume resiliency. Does that help improve reliability in Azure HCI?
As in going from, say, two-way mirror to three-way mirror, etc.
Yes.
Does it help improve reliability? It improves, right, so two things. On an incorrectly configured system, no. That's point number one. A badly configured or deployed system isn't going to work whatever you do with it. On a correctly deployed and configured system, when you go to three-way mirror, you are gaining more resilience to failure, right? Mm-hmm. And that's the important thing. So yes, you are improving reliability, but I oddly, when I think of reliability, I think about failures that are happening not due to system by design, right? Whereas reliability in terms of two-way versus three-way mirror, I see that as a normal fault condition. In other words, if you're two-way mirrored, you can lose one node and you're fine. In a three-way mirror, you can lose two and you're fine. So it increases reliability, but not its, I'm trying to think how I describe this correctly. That I consider to be just normal functionality. Does that make sense?
Okay.
Yes, but I see where you're going with this, and therefore let me give you another example. On a two-node system, I would always use nested parity or nested mirror, because otherwise, as soon as you lose a node, if you lose another disk on the second node, you have lost your entire system completely, which is catastrophic. And also remember, everyone, let's think about a system that's, say, got 4 nodes or above. Even if you're using three-way mirror, you can lose 2 nodes, but if you lose a single disk in another node, you have lost your entire storage pool.
Yep.
Yeah, you know, not oh, I might have a problem. You've lost everything. Yeah.
Yeah.
Indeed. Yes, indeed. What's interesting, though, and perhaps we'll save this for another session. We'll have a conversation about scoped volumes and about how you can limit the number of nodes and the volume spans, which can actually drive up availability. Scoped volumes is a very, very, very little used feature, but it's incredibly powerful and flexible when used well.
Good, very good point. I think that the group will be very interested in scope volume. It's just that I think we need a bit more time to expound on it.
We do. It is a subject in its own right. And in fact, if we did scoped volumes and cluster sets, in fact, let's save this for a topic of another time. So we'll do cluster sets, scoped volumes, and storage and compute only nodes.
Ah, okay.
Which is technically, so it's technically not there, but it is because they never took the code out of 2019. It's actually in 2019. They just never officially shipped it.
Sorry, what was that again?
Okay, so storage and compute only nodes inside of the same cluster. The functionality is there. They just never officially shipped it.
I didn't know there's such a functionality.
I know, because they want, because it's so similar. The point is, cluster sets do a very similar job. So let me give you the inside dirt on this conversation. So
Sure.
cluster sets was only created to keep the Azure Stack Hub team happy, because they were going to use it to allow them to do multi-rack single ARM. Okay, right. Then they decided not to use it anymore, right? So they abandoned it. Independently of that, they were looking at doing, or they built storage, so you could have nodes that only did storage and nodes that only did compute inside the same cluster, right? And that code is in there. It actually was in Server 2019. What happened, though, is because cluster sets got abandoned by the Hub team, the Windows Server team had to endorse it. So instead, their way of doing large scale-out clusters was using cluster sets. The idea was it would create a single cluster set, and some of the clusters would be compute and some of the clusters would be storage only. So that was their way. But you can actually mix storage and compute only nodes inside of the same cluster. In fact, you can see the functionality stay in 21H2 because it's that same logic that allows you to have some nodes that have GPUs and others that don't inside the same cluster.
Right. Yeah.
Yep.
Okay.
Yep. It's that code base. Yep. In other words, Microsoft's incredibly lazy and never actually does anything new and just regurgitates their old code. Yes, indeed. Yes, indeed. Cool. Okay. Other things. I'm sure we've got some questions. So we've only got about 10 minutes left. So if anyone's got any questions or thoughts, it'd be lovely to take them.
Yep. If anyone has questions, please feel free to unmute and ask. Alternatively, you can drop them into the chat window.
Yes, but I like that person. So the question they put into the chat is, yes, is two-way versus three-way more to do with resiliency and reliability? Yes, I would absolutely view it that way, because resiliency is a functionality of design choice, whereas reliability is a byproduct of correct configuration and design in the first place. So yes, I would absolutely say two-way versus three-way, etc., is a resiliency conversation, not a reliability one. Utterly agreed. Yes, indeed. Good. Other questions?
If there are no questions, or you can't think of one for now, maybe this third question could be the question. What do you think, Phil?
Indeed. Okay, so let's think about this. Yes, exactly. So actually, there's 2 ways of looking at this, right? If you're talking to an SME, and when I chat to SMEs, this is the thought process I always go through them. First question is, that's the very first question is, dear SME, do you require on-prem IT infrastructure full stop, right? Because if they're really small, actually they could just be Microsoft 365 and, OneDrive, right? You know, that's point one. You know, even if they've been running an old file server, you know, they might be able to just move purely to cloud. Let's assume though they want to keep stuff on-prem. The next conversation with the customer is, do you need, you know, server level high availability on-prem, right? Because if they don't, the best option is in fact Windows Server with a RAID card. That makes sense, right? The next question is, do they use or want to use Azure as their primary management experience, right? If they do, it's Azure Stack HCI single node. Okay, right? And this is really the conversation to go through. And remember, you know, these things can get really small. So, you know, Azure Stack HCI single node now can start only having 2 disks in it. So in other words, it can almost be a PC, actually. So you can drive some incredible price and performance into these sectors. But the last thing is, and I'm actually going to close this comment with my opening one at the beginning when I started this conversation an hour ago. Remember, the best system for your customer is the one that meets their needs but doesn't do anything they don't need. That makes sense?
Yep.
Because there's no point giving someone a cheap system that actually doesn't do its job, nor is there any point giving somebody a hugely powerful system that's overkill. So actually, the best value system is the one that does the job to meet the client's requirements.
Agree?
Yes, I did. And I think that's absolutely the critical takeaway. And one of the things I know, you know, Hitan's listening on this call, and Hitan and I bump into this a lot. Salespeople who try and just sell something rather than the right thing. So either they sell the customer complete overkill that's a waste of money, or something that was completely under spec or not appropriate, cause them spend more later on, which is why correct planning and understanding of clients' business requirements should always be what drives all of our engagement with customers.
Very good point. So
yes.
If the salesperson says best value for performance is 2 SSD and 4 spindle drive, and that meets the requirement of the customer, then obviously the solution would be the right solution for the customer, right?
Correct. Yes, indeed. And let's come at this from that very angle. The right solution is the one that meets their needs with the minimum hardware cost. So yes, correct. You know, the wrong solution to use, for example, is if the salesperson has said, you know, the same node configuration but using pure NVMe, because that would have cost the customer more and it would have been overkill.
So how would we derive that right solution for a budget constrained SME?
Well, what's really interesting, and now I'll do the architect sales pitch, which I wouldn't normally do on this call, but as Hitan mentioned it earlier, you know, of course, as you know, we have the scoping tool that some vendors, Lenovo, use it a lot. We call it Scope System. That makes it very, very, very easy. But of course, what that tool does is it does all the math under the covers to right size the system based on the client's requirements. And in fact, what we could do, of course, is do another call on the scoping tool as well at some point in the future, or we can let Hitan drive that meeting if we like. Because actually, and the reason I want to talk about it from this point of view is that the maths to correctly figure out the right hardware components that deliver on a certain spec to meet a certain requirement is actually very complicated, right? And for those of you who don't know, Architect has this tool, we call it ScopeSys, where the actual engine inside of it actually mimics an Azure Stack HCI system. So it does all the computation that S2D does. It understands SDN, it understands Hyper-V and the overheads. So you feed it, what the user's requirements are in terms of virtual machines or storage requirements or daily working set, as Hitan mentioned earlier. And then it literally throws out a number of configurations that's both in terms of hardware, bill of materials, and node count. And one of the things that actually does is the first solution it returns is the most cost effective, right? So it returns a number of solutions, all that are technically suitable, but the one it recommends as the primary option, for use of a better term, is in fact the most cost optimized one. So I would highly recommend we do a session on that, again, at some point in the future.
Okay. Okay.
Yes, indeed.
Very
If
good.
only because it's good fun working with people who understand how Storage Spaces Direct works, because I'm sure you'll be like, oh, that's interesting. What about this configuration? So they're always good fun, those sessions.
Excellent. So I suppose we can probably convert this question into something that can give us very numerical outcomes in a sizing tool.
Correct. And that's the point. Yes, because coming back to the point, value and performance is based on client requirement and always is. So there is no simple answer, which is a SME needs 2 spinning spindle systems with an 8-core CPU, because that isn't the answer. Yes, it is a numerical decision in all cases.
I think that's where the tools like, like live optics and stuff like that should help get that data from the customer's existing environment, should drive probably a better configuration, what suits them.
Theoretically, yes. However, I'm now going to say something else controversial here. I hate live optics. Let me tell you why. And I hate all the other telemetry tools. The reason is not that the tools are bad, but they have 2 key problems. The first thing is the tool only knows about what the customer's currently got. And the problem is that their system, if they're trying to replace it, probably isn't running optimally or is overly saturated. So when it talks about the IOPS or the RAM or the CPU and the IOPS consumption that each workload is actually requiring, it's quite likely it's not actually giving the results of what the apps really need in an optimum environment. It's probably giving the results of what the system can drive. That's problem number 1. Problem number 2 is that those systems inherently don't know about the future. Now, personally, I actually like asking the client and actually talking them through it. However, I also absolutely recognise that customers invariably don't actually know what's in their system, and therefore things like live optics are very helpful for giving people an idea of, what they have got to help frame the debate. So I hope that kind of, answers the viewpoint. But I'm also very aware that my viewpoint of things like live optics is probably, shall we say, in the minority. But as we all know, I'm a, follically challenged, bold so-and-so.
No, I agree. So I think, what I was trying to alluding to is basically that's one of the, metrics that we can rely on, but there are a lot of other things that we need to understand. What is the kind of system that they're currently running? What's their use case? And, that's the other side, other bits of the conversation. But
absolutely,
this just things.
Yes, yeah. It is a tool that is part of building the picture. And I think I'm really glad you framed it that way, because that is exactly what it is. It is not an answer to everything.
Okay.
Yes, utterly agreed. I'm conscious we're at the hour, but are there any other questions today?
I think the audience is probably a bit overwhelmed. All right. I don't think that had anyone as outspoken as you been. All right. But I'll let the audience review the video, and I'm sure out of that, they will probably have stacks of questions.
Of course.
And what I'll do is I'll get them to continue to drop them into this chat window. All right. But I just need everyone who's joined this session to help us fill up the feedback form, because that's valuable to guide us in where we're going. All right. Is there any one last question for Phil before we let him go? Okay. They want your LinkedIn ID.
As we all know, I don't have social media, but I will refer to Hitan here, who does. So what I would suggest is if you connect with Hitan and they have a direct way of getting hold of me. So yes, indeed.
How about the traditional email?
Indeed, yes, indeed. Hold on. Let me try and type that into the chat. 1 second. Here we go.
We can help you out with that, Phil.
Oh, okay, if you could put it in for me, thank you so much. Thank you so much. Yes, indeed.
I had it in the EDM, so I'll drop that into the into the chat window. But if there are no questions, we want to give Phil a very big round of applause and thank you.
Well, thank
right.
you everyone
Helping
so
us
much.
with it.
It's been an absolute pleasure. And actually, it's been so nice doing it on the same time zone again for a change. It's been really nice. Yes, you know, being evening for all of us. Thank you all.
Thank you, Phil, and a wonderful session coming up. I believe in a couple of days you have a session in Singapore, right?
Yes, indeed. Yes, at the, I'm sure Hitan will intervene there, at the hotel where the Singapore sling was invented, apparently. Yes.
Cool.
The Raffles
Raffles.
Avenue.
Yes, the Raffles. And
Yeah.
I'm told it's quite nice, apparently.
Oh, it's fantastic. Don't miss the Raffles Avenue, especially don't miss the peanuts there.
The peanuts.
Oh yeah, so you get to peel your peanuts and then throw it on the floor. So the entire floor is flooded with peanut peels, and you just walk onto on the peels and then have the Singapore sling. So that's one hell of an
Interesting.
experience.
I thought this was an uphill place. Clearly not. Right.
Oh, it's beautiful. You should go there, Raffles Avenue, and especially in this particular
Interesting.
shop. Yep.
Interesting. Thank you. I shall look forward to. Although one of my favourite hotels is the hotel by the Petronas Towers, which I do like the Petronas Towers a lot. Yes.
Oh,
Yeah.
I do like it over there in KL. Anyway, gentlemen, thank you, and gentlemen,
Thank
ladies,
you.
thank you so much.
thank you, Phil.
Thank you.
You too.
Thanks,
Thanks,
Phil.
guys.
Thank you so much.
Thanks, Phil.
Thanks, guys.
for this.
Thanks.
Thanks, guys.
Bye-bye.
Have a good
Thanks for
evening.
the
All
great
right.
sharing.
Okay. Thank you so much. God bless. Bye.